Good afternoon to Dr. Hazalila binti Kamaluddin. We are from Group 14. First of all, I will introduce to you my group members, Nitiswaran, Chai Ziahui, Liu Yizi, and myself is Noriza Nazrina binti Muhammad Salmi. First of all, I will explain about part 1 first. For our project title is Designing an Efficient Small Office Home Office SOHO Network with Guest Access, a comprehensive guide. For project scope, to design a SOHO network, consider expected functionality and future growth, use standard components from proven brands, and ensure fast equipment like standalone modems, routers, switches, and access points. 3-band routers prioritize important data, and mesh Wi-Fi systems are ideal. Buy a good router with must-have features like Ubiquiti Unified USG and each router X. Create a guest network for secure guest access. Use a bill of material with appropriate products and multiple routers for optimal functionality. For network requirement, analysis is the process of identifying and analyzing the needs of organizations' network infrastructure. This involves considering factors such as the number of users, the type of application being used, the amount of data being transferred, and overall performance requirement of the network. The analysis typically involves assessing the current network infrastructure, identifying areas for improvement, and developing a plan. This process is critically for ensuring that the organization's network is capable of support its current and future needs and can help minimize downtime, improve productivity, and enhance overall efficiency. For network planning, we are divided for 5 tasks. First task is planning layout. Assigned person is myself. Configuring the network, setting up the guest network, and testing the network. Assigned person is Liu Yizi. And the last task is selecting the right components. Assigned person is myself, Noriza Nazrina binti Muhammad Sami.
So following on, I will present about the IP network design table. The IP network design table outlines the IP address allocation, subnetting, and routing for an efficient network setup. To accommodate the 60 hosts on the LAN, a subnet with a prefix length of 26 is used. The subnet mask associated with this prefix length is 255.255.255.192, providing an IP range of 199.140.140.0 until 63. The guest network requires 12 hosts, which can be accommodated with a prefix length of 28, and 199.140.140.64 to 79 IP range can all be specified. Assign a separate subnet to the server network, which requires 3 hosts with a prefix length of 29, and an IP range of 199.140.140.80 to 87 is required. Finally, create a router-to-router connection with a prefix length of 30, and the IP range is 199.140.140.88 to 91. Next, I will present about the physical topology for part A. So the network setup includes 3 main areas. First is the server room, second is the main office, and the third is the guest room. The server room is where servers like the DNS server, FTP server, and also the web server are typically located. The host hosts support these servers, which are positioned on route 2, self 1, 2, and 3. Additionally, there's a switch at route 1, self 3, a multi-layer switch at route 1, self 2, and also got a main router at route 1, self 1. Besides that, the main office has 60 PC and a few switch. The PC use i5 processor. The main office also includes 3 switch positioned on self 2, 3, and 4 in route 1, along a multi-layer switch on route 1, self 1. Lastly, the guest room features one multi-layer switch on the rack 1 cell 1, a switch on rack 1 cell 2, and also 12 PC for visitors use. So going on, I'll present about the logical topology for this design. The logical topology of the Soho network design with a guest network, as shown in this figure, follows a hierarchical model consisting of the core layer, distribution layer, and access layer. The R1 router functions at the core layer, facilitating high-speed traffic management between distribution layer devices, data centers, and external networks. The distribution layer contains three multi-layer switches, which are MS1, MS2, and MS3, that connect the core layer to the access layer, enabling traffic flow between different access layer switches. The network design includes two routers, which are an ISP router and the R1 router connected via a serial cable. The R1 router is further connected to three separate subnets representing LAN segments, guest segment, and also the server segment. Each subnet has its corresponding switch and devices such as user PC, guest PC, and servers with the assigned IP address. The design provides scalability, flexibility, and efficient traffic flow for the network infrastructure. That's all for the logical topology.
For bill material, we have list down for 8 materials that total price is more than 200,000. First of all, we are list router, and then multi-layer switch, FTP server, web server, DNS server, and for the fifth material is PC. We are use Dell Desktop Micro Optiplex, and the sixth component is copper crossover cable, and then copper straight through cable. Next is copper straight through cable, but with the different length. And last item is serial DCE cable.
Hello guys, my name is Nitishwaran and now I want to present about the project title and the scope. So for the main campus, we have 230 students with 20 students in building 1, 50 in building 2 and 160 in the main building. So each building has a 500 square foot open lobby with wireless network connectivity. So, as the main building has a high-speed cable internet connection, while a branch campus has only 100 users. Okay. Then we have a server farm with web, email, DNS, and DHCP servers will be built with the unique subnet. Essential hardware, architecture, IP address management, secure wireless access, and internet sharing features and services are determined, and products from Microsoft, Cisco, D-Link, or Netgear are used for campus infrastructure. So that's all from me for the this part. Hello guys, now I want to present about the campus diagram. So as you can see, the first image is image of the main campus and branch campus. So if you can see, the distance between the main campus and branch campus is only 5 kilometer. So the next one is the buildings in the main campus. The figure shows the buildings that located in the main campus. So as you can see, there are three buildings: main building, building one, and building two. So from main building to building one, the distance between both of them is 500-meter, and the building one to building two is distance between them is 200-meter, and the main building to building two is only 100-meter. So as the last image, you can see the overview of campus diagram. So the total distance between the main campus and branch campus is 10 kilometer. So this is our project's campus diagram. So that's all from me. Thank you.
Good morning, madam. I'm Choi Xiaohui, and I will now present about the network requirement analysis, physical topology, logical topology, IP network design table, and bill of material. For the network requirement analysis, The network requirement analysis including the understanding of the hardware and quantity needed to build a network. The study take into account elements including the organization size and structure, user count, type of application and service to be used, and expected network performance. Therefore, this project may have a main building that needed to work on the number of users up to 160 users. It will have one router and an ISP router in the core layer, two multi-layer switches in the distribution layer, two switches, two access points, and four PC in the access layer. And it will also have a server farm which have four servers and one switch. Then for the building one, it will use by 20 users. The building one will have two multi-layer switches in the distribution layer, one switch, one access point, and three PC in the access layer. And the building two, which used by 50 users, it will have two multi-layer switches in the distribution layer, two switches and one access point, and three PC in the access layer. Then last is for the branch building, which used by user up to 100 users. It will have one router and one ISP router, two multi-layer switches in the distribution layer, two switches, two access points, and four PC in the access layer. Next, for the physical topology, the physical topology comprises the technique used to link the cable to the device on the network and the kind of wire that are utilized. This topology will state the location and device information. For example, the web server, email server, DNS server, and DHCP server are placed in rack shelf 2, shelf 3, shelf 4, and shelf 5 of the server farm wiring courses respectively, and the server switch is placed in the same rack but in shelf 1. However, the main router, main ISP, main switch 1, main switch 2, main multi-layer switch 1, main multi-layer switch 2, main access point 1, and main access point 2 are placed in the rack 1, 2, 3, 4, 5, 6, 7, and 8 respectively of the main building wiring courses. In addition, the personal computer PC1, PC2, PC3, PC4, and PC5 are placed in room 1, room 2, room 3, room 4, and room 5 respectively. Then the server farm wiring courses and main building wiring courses are placed inside the main building. Next is the logical topology. The logical topology in computer network refers to the conceptual configuration of network element link and protocol that define how data is routed across the network. It will have the labeled IP address inside the logical topology. For example, building 1, it will have two multi-layer switches that has been configured as IP address 199.140.141.194 and 199.140.141.9195. Then the switch has been configured by IP address 199.140.141.196. For IP network design table, in this table it will have several elements which are the given IP, range of subnet address SA, subnet mask SM, number of hosts supported (N#S), number of hosts needed (N#N), usable address range (AR), broadcast address (BA), gateway address (GA), and assigned to AT. In this table, the first row of the table shows the maximum number of hosts needed to help design the IP network, and the second row is the second largest number, and so on. Then last is the bill of material. In this project, we will provide a bill of material which is a detailed list listing all the raw material and components needed in finish it. In this table, we can see we need 330 PC, 4 server, 7 switch, 8 multi-layer switch, 6 access point, 4 router, 1 serial DCE. Next, we will also need 100 meter copper structure and 22 10 meters copper structure and 20 copper crossover. In this table, it will show the quantity, the price per unit, and the total price, and also summary of the total price of all elements. Thank you. That is all of our group for the presentation video, and we will proceed to the demo.
Hello, good afternoon, madam. Going on, I will demo the packet tracer for our pub questions. So first of all, we can see the blue area here is the subnet 3 for the server network, and the yellow area here is the subnet 1 for LAN network, and also the green areas for the subnet 2, which is the guest network. So now we can see all the router and switch have been configured. So we can see from here, the IP address has been assigned to each related port, and also the switch you can see. Yeah, the VLAN 1 IP address has been assigned and they are in up status. So next I will test for the ping. So first of all, I will ping for the guest PC first. So we go to the desktop command prompt, and then we ping to the FTP servers based on our caches requirements. Ping the IP address of FTP server is 199.140.140.82, and then we click enter and we wait for the result. Yeah, the result shows they are successfully connected between the PC guest and also the FTP server. So next we try to ping to the user PC. So we ping 199.140.140.2, which is the IP address from the user PC, and then we click enter. Yes, it will show the destination host unreachable. This is because we set the SCL to we block the users to access the user's network, but we allow the guest to access the server network. So that's all for the PC guest part. And later we test for the LAN network. And for here, we just click here, desktop command prompt. And firstly, we need to ping to the server. So let's say I ping to the web server 199.140.140.83. And then we see the result. Yeah, the result shows the ping between the PC3 and also the web server are successfully. Okay, so that's all for the ping test. So later, I will show the functionality of our FTP servers. So for our FTP servers, firstly, we try for the FTP servers. We go to the services and we're going to find FTP. And from here, we can get the username and also the password. Let's say now I set to try, password also try. Then I just click write, read, delete, rename, and list. Then after that, I click it. So after that, I go to PC like the PC guest. I go to the command prompt. I just type FTP and then the IP address 199.140.140.82, which is the IP address for the FTP server. Then click yes. They will ask for the username and password. Just now we set try password also and enter. Yes, we are logged into the FTP servers, and for now we can read, edit, delete, or rename. There's a lot of operations that we can done, and later we can just click for FTP server. So the next is the web servers. The web servers, we also go to the services and go to HTTP, and then we can see a lot of files here. So let's say we choose one file, home HTML, we click edit. Okay, now we change some word like PCNA, and then we click. And after that, we choose text. Yes, and then we click leave. So after we choose one PC, let's say PC3, we go to the web browser. Yeah, we type the URL. URL, we can just type the IP address from the web server 199.140.140.83. Just now is the home.html. Is the home.html. HTML. Then we just click enter. Yes, it will show the web browser for welcome to CCNA that we have modified there. And the third is the DNS servers. We also go to service file DNA. And then let's say now we put the name DNS. The address of DNS server is 199.140.140.84. And then I click it. And I add one more to PC1. The address of PC1 is 199.140.140.2. And then click it. So now we just go to the PC1 here. And we go to the desktop command prompt. And we ping to the DNS servers. For this time, we not need to ping for the address. We just ping DNS and wait for the results. Yes. There's successful ping between the DNS server and also the PT1. So that's all for the demo part for part A. Thank you very much.
Good morning, madam. We are from group 14. This is the packet tracer for our group of part B. Then we will start to demo now. So here is all the building inside our packet tracer. For the blue frame is for the main building. Then the orange frame is for the server farm. Green frame is for the building 1. Yellow frame is for the building 2. And the pink frame is for the branch building. Then you can see that the main router has configured of all the IP address into the port, and then we now will start to test the email server. For the email server, we will need to add 2 devices first. Then we will add the main PC2 and building 1 PC2. After that, we open the main PC2, click on email and fill up all the information. And here we need to fill up the IP address of the email server. And click on save. Then we open the building 1 PC2. Then we will start to send email between these 2 devices. First, we will send email from the main PC2 to the building 1 PC2. Click on send button and we can check on the building 1 PC2 receipt. Then it will appear the message and we can reply it. Then we can check also in the receive button at the main PC2. Then the reply message will appear. After that, we will test the web server. Inside the web server, we have create a website for it. And then we click on random PC, for example main PC5. And then we click on web browser. After that, we type the IP address of the web server. And it will appear the message, the website that has created in the web server. Then we will ping the main PC to the building 1 PC. The building 1 PC1. And it will show successfully ping, and then we will ping back to the main PC1. And it will also show the successfully ping. After that, we ping the building 2 PC1 from the main PC1. And it will show successfully ping, and we will ping back to the main PC1. And it will also show successful. Then we will try to ping to the branch campus. Branch campus PC1. So it will also show successful, and then we will try to ping from the branch campus PC1 to the main campus PC1. And it also will show successful. Then this will show that all the ping is successful, and that's all from our group. Thank you.